So I'd like to extend our number line beyond the bounds that we had in the last video, and part of that is to look at the patterns that emerge when we start to work out logarithms in different orders of magnitude. So we're going to continue with, so on here at the top we've got our logarithms, and here on the bottom we've got our normal numbers. So previously we had normal numbers from 1 to 10, so therefore the logarithms were going from 0 to 1, because 1 is 10 to the power 0, 10 is 10 to the power 1. So now we're just going to expand, so we've got 100, which is 10 to the power 2, 1000, which is 10 to the power 3, so these logarithms are 2 and 3. And then 0.1 is 10 to the power minus 1, so that the logarithm is minus 1. And for the logarithm minus 2, 10 to the minus 2, 0.01. Right, so we're going to fill in some of these gaps. So this is logarithms in base 10, of course. So how about if we got the logarithm of 20? So just using the strategies from elsewhere, so logarithm of 20 is logarithm of 2 times 10. So therefore, in fact, let's move this down a little bit. I'm going to want some room in a minute. So logarithm of 2 times 10, so that's logarithm of 2 plus logarithm of 10. So we know from our table here that logarithm of 2 is 0.301, logarithm of 10 is 1, so that's 1.301. Let's put that in here. So 1.301 is about here, and that's 20. Now how about logarithm of 70? So that's the log of 7 times 10, so that's log of 7 plus log of 10. So we could think of 10 as 10 to the power 1. That'll be helpful to us later. So log of 7 is 0.845 plus 1. Log in base 10 of 10 is 1. So 1.845. Let's draw that on. That'll be up here somewhere. Cool. We could just do our 2 and our 7. Let's do that. So that's 0.301. 0.845. Now how about if we want to fill in this order of magnitude, so if we wanted the log of 200, that is the log of 2 times 100, which is the log of 2 plus the log of 10 to the power 2, because 100 is 10 times 10, so 10 to the power 2, that's 0.301 plus 2, so that's 2.301. And the logarithm of 700 is the logarithm of 7 times 100. So that's the log of 7 plus the log of 10 to the power 2. So that's 0.845 plus 2, so 2.845. Let's put those on. So that's 2.301 and 2.845. So I hope you've noticed here that this 301 stays the same, so that represents our 2, it's something times 2, and then this first part the stuff that goes before the decimal place corresponds to our power of 10. And same here, so this is 10 to the power 2, so it's 2 here. Good. Let's get rid of these circles. Right, so that's what I want to say about that, I think. So this is 2, this is 7. Now how about these numbers that are smaller than 1? Numbers that are smaller than 1 have negative logarithms, but it's just the same principles. Here we've got logarithm of, let's say, 0.2, so that's the log of 2 times 0.1, so that is the log of 2 plus the log of 10 to the minus 1. 0.1 is 10 to the minus 1. So log of 2 is still 0.301. And 10 to the minus 1, so that's minus 1 for the logarithm of this part. So that is minus 0.699. So that goes here somewhere. Same idea, log of 0.7, so that's log of 7 times 0.1, so that's log of 7 plus log of 10 to the minus 1, so that's 0.845 minus 1, so again this minus 1 comes here, so that would be minus 0.155. So that would be up here somewhere. And let's just go one more order of magnitude out, so that's log of 0.02 is the log of 2 times 0.01, or the log of 2 plus the log of 10 to the minus 2. So that would be 0.301 minus 2, or minus 1.699. So you'll notice this 699, again, is the same, because that corresponds to 2. And then the order of magnitude is taken care of behind the decimal place. And finally, log of 0.07, so that's the log of 7 times 0.01, which is the log of 7 plus the log of 10 to the minus 2. I don't quite have room, so we'll just skip to the final answer, which is minus 1.115. Same idea. And let's just add these on, and then I think that's all I have to say about that. Okay, so you'll note that the this 2, so the factor within the order of magnitude is taken care of after the decimal place, whereas the order of magnitude itself is in front of the decimal place. And also I'd like to make the point that, so all these numbers, so where the normal numbers are smaller than 1, then the logarithms are going to be smaller than 0. And that's generally true, so that's a good clue. And I think, yeah, there's some good tips, I hope, that can help you estimate what's going on with your logarithms.